In today's lesson, toda kuita a summary of sequences and series. Saka toda kungoita list all the formulas which are necessary nekungo discuss this topic in summary. Saka firstly, toda ku define what a sequence is. So when it comes to a sequence, takati this is an array, tinogona kuita arrangement, tinogona kuita list of numbers with a specific kana kuti particular pattern, tinogona kuti order, tinogona kuti relationship. Saka this is a summarized definition of a sequence. This is an array, this is an arrangement. It's a list of numbers with a specific particular pattern, order, or relationship. Then an example we can give panapa, a very simple example. Tinogona kuita ma multiples of 2, which are what? 2, 4, 6, 8, and so forth. That is what a sequence is. Now when we talk about a series, tikutaura pamusoro pe the sum of terms in a sequence. That is what a series is. Sum of terms in a sequence. And buying from this example, tinenge takungoti 2 plus 4 plus 6 plus 8 plus and so forth. So a sequence, this is used to describe an array of numbers following a specific order or pattern. And that's an example, the multiples of 2. That's for a sequence. Then for a series, this refers to the sum of numbers in a sequence. Saka ma numbers in a sequence, we usually call them terms. So the sum of terms in a sequence, and an example would be 2 plus 4 plus 6 plus 8 and so forth. Saka, these are the definitions of terms. From there, let us now move on to notation. Saka takatarisa notation, takati isusu, tikaisa yuna n like this. This means the nth term. Saka kuti nth, zviri kungobva pakuti we do not know the particular term. Saka it's an unknown kana kuti variable term. Saka n ari kushanda in place of a term we do not as yet know. Saka un, that's the nth term. Then from there, takataura about a, which is the first term. Takataura about n, which represents a position of a term. Saka this is a position of a term in a sequence. That's what n represents. Takataura about d, which is very important, a common difference. But just to preempt, a common difference is associated with the arithmetic progression, kana kuti an arithmetically progressing sequence. Then r, which is a common ratio. Takataura about a common ratio as referring to a geometrically progressing sequence or just a geometric progression. Then lastly, L, represent the last term. This is what we learned. Tabva panapa, takabva tazoita double down on types of sequences. Saka when we look at types of sequences, the types of sequences we looked at were the arithmetic progression, takatarisa zvakare geometric progression. So arithmetic and geometric progression. Now when we look at the arithmetic progression, what do we learn from the arithmetic progression? Takadefine in arithmetic progression as a sequence in which the difference between any pair of successive terms is uniform. Saka we associate arithmetic progression with D representing a common difference. And we said this common difference should be what? It should be uniform. Then we also gave an example panapa. The example we gave was this. Let us say tina 100 as our first term, to end up on 95, 90, 85. Saka iyo D yacho manje inenge iri equal to term iri kumberi ne term minus term iri kuzasi. Term iri kumberi ndo inenge iri chi proceeding term. So it's proceeding term subtracting term iri kusure I preceding term. Saka this is very important. Pana D papa pando pano define kuti tine arithmetic progression if we have a uniform common difference like this. So applying this relationship trikungoti 95 minus 100 tinoona kuti ndiani having 100 95 90 85. 95 minus 100 tinoona kuti pakati panapa panenge paina minus 5. 90 minus 95 ndi minus 5 again, and 85 minus 90 ndi minus 5. Saka since panapa we can clearly see kuti D is equal to minus 5 and it's uniform. Zvinoreva kuti we have an arithmetic progression. So the first thing you are going to see when we start practicing with examples, the first thing which you should be hands-on with, chinhu chekutanga kugona kudefine kuti question yatapiwa ine arithmetic progression here kana kuti ine geometric progression. That's very important. And kuti tizive kuti arithmetic progression tichatsvaga a common difference which is uniform. Now after taziva izvozvo, depending with the type of question we are answering, we are going to be concerned with an nth term. So what do we mean kana tichiti the nth term? Remember tadefine n as a position in a sequence, and saka kana tichida the nth term, and we are going to use this simple formula un, and which is the nth term, is equal to a plus n minus 1 times d. So this is very important. This is the formula we are going to be using. Ati remember kuti tinoshandisa this formula kana iri nth term maringe ne arithmetic progression. That's very important there. So kana tichiti nth term, for example, tanga tine ka sequence kedu kakadai so, like this. Saka nth term tinogona kubvunza kuti what is going to be the 8th number, and saka n inenge yadefinwa as 8. Tiri kutsvaga the nth term but taudzwa kuti n iri equal to 8. So the 8th number kunenge kuri kungoti u8 is equal to a zoreva the first term which is 100 plus n, that's 8 minus 1, then the common difference in this case is minus 5, like that. Then we can simplify this. It becomes 100 plus 7, but this 7 is multiplying negative 5, kureva kuti 100 subtracting 35. Tikati 100 minus 30 tinowana 70. Saka tikazoti 70 minus 5 it's 65. Kureva kuti 65 ndiyo the 8th term. Kuri kuti taipedzisa panapa, and apa 85 so rata apa inenge yachi kuri kuti tiri kuda kupedzisa, zvoreva kuti panapa inenge iri 80, 75, 70, 65, 60 and so forth. Mukada kutoverenga panapa first term 1, 2, 3, 4, 5, 6, 7, the 8th term sekuiwana kwataita panapa. So mufanirwa kuunderstanda kuti kana tichiti nth term tikureva kuti tapiwa position kuti tikuda number yechi 14 tapiwa an arithmetic progression, tinoiwana say the nth term, which is denoted un, is equal to a plus bracket n minus 1 times d. That's very important. Now the other thing we are interested with, it's the sum of n terms. Saka tinotarisa zvakare sum of n terms. Sum of n terms manje iri kureva kuti kuri kuti tina 100, 95, 90, 85. Sum of n terms tiri kuti S4 zvoreva kuti we are adding the first 4 terms like this. Ndokuti sum of n terms, adding the first 4 terms. So we are going to use two different formulas dependent on the information we are given. Kana tisina kupiwa the last term, it's going to be Sn is equal to n over 2. That n over 2 yacho iri kumultiply yachi 2a plus n minus 1 d like this. And oro kana takapiwa a last term, it becomes more easier. Sn ingeri n over 2 a plus l. In this case takapiwa the last term, which is 85, kureva kuti we can use the simpler version of the formulae. But these are the formulas we are interested with, like this. Mapaona. Saka ndo zviri kutaurwa kuti iyo Sn ish kana kuti S4 tichida kutarisa what it really means. It simply means 100 plus 95 plus 90 plus 85. But isusu tinozoshandisa yedu the formula S4 is equal to, since tine the last term 85, inenge iri n anenge ari 4, so it's 4 over 2 a, that's 100, plus l, the last term, that's 85, like this. We are going to get the same sum, the same result. Saka the nth term tapiwa a position of a number in a sequence, tofunza kuti number yacho inenge imbori chi. Sum of n terms tapiwa number of terms we have to add, tofunza kuti the sum yacho inenge imbori chi. So kuti if we are to really look closely, we are going to see kuti pa sum of n terms ndo patakutotaura about chi, the series. Mapaona. And pa the nth term tiri kutsvaga the position of n in a sequence. Saka sum of n terms, it's really connected to a series. Now going to the second part, patakaita a geometric progression, a GP. We defined a GP as what? As a sequence in which any pair of successive terms give a uniform ratio. Saka we associated a GP with R, which is referring to a common, we can equally call it a uniform ratio. And this common uniform ratio R inge equal to the preceding term. Kuroti term iri kumberi in a sequence dividing the preceding term. Kureva term inge iri kumasure in a sequence. And it's something like this. Ndo zvakaita izvo. Like that. Very important. Andika. Saka taona kuti a GP is associated with the common ratio, which is preceding term over preceding term. Takuda kuziva the nth term. But panapa fair to have an example. Saka example ye a geometric progression, we can look at 2, 4, 8, 16. Common ratio irapa kuri kuti tada kutsvaga r inenge iri equal to 4 over 2. Tinoona kuti ndi 2. Tikada kutsvaga r tichishandisa 4 na 8 inenge iri equal to 8 over 4, which is also 2. Tikada kutsvaga r tichishandisa 16 na 8 inenge iri equal to 16 over 8, which is also 2. Saka pana patirikuona kuti pana times 2 times 2 times 2 kureva kuti r is equals to 2 ndiyo common ratio yedu. Anditika? Okay. Saka kana takuda kutsvaga the nth term, toda kuziva kuti term yechn inenge iri chi in the sequence. So pakutsvaga the nth term manje, formula yatinoshandisa, the nth term is equal to ar to the power n minus 1, like this. Ar to the power n minus 1. Ndichazoisa ma formulas aya side by side kuti muone ma differences aripo, but it's ar to the power n minus 1. Okay, that's how we find the nth term. Kuri kuti tanga tida kutsvaga the third term panapa, just a quick example. Term number 3 yatiri kutoziva beforehand kuti anenge ari 8 inenge iri equal to a, which is the first term, 2 times 2, which is the common ratio r, to the power n minus 1, n upon the 3 minus 1. So this is 2 to the power 2, 3 minus 1 the squared. So apana patikuti 2 squared, which is 4 times 2, 8. That's the 8. Saka this was just a quick illustration of what we are talking about. From kuana the nth term, we now have to consider the sum of n terms. The sum of n terms sekutaura kwataita sum of 4 terms inenge iri 2 plus 4 plus 8 plus 16. But we have a general formula inoti iyo Sn is equal to a 1 minus r to the n over 1 minus r, like this. So this is a formula you have to submit to memory. Kuroti zvatanyora apo, sum of 4 terms can be given as first term di 2 toti 1 minus r ndi 2 zvakare to the power n, which is 4 over 1 minus 2, which is simplified to 2. Then apo it's 1 subtracting 2 times 24, 4 times 28, 8 times 2, 16. So 1 minus 16 over negative 1, which if we want to go further with it will be 2 multiplying negative 15 over negative 1, which is minus 30 over minus 1, which is equal to 30. So kuti mukato add down tikabvisa 1 panapa, ngatiti 16 plus 4 ndi 20, 8 plus 2 ndi 10, saka 30 irubva yabuda yakanaka. Mapaona. Saka pa geometric progression tinotsvaga futi the nth term, we have a formula. Tinotsvaga futi sum of n terms, we have a formula. But tinobva tazoenderera mberi manje. Kumberi kwatinoenderera tinenge takuchitsvaga yavanoti iyo sum to infinity. Saka ku AP hakuna sum to infinity, asi ku JP ndo kunechi sum to infinity. Now chinonzi infinity, this is a state of unending. And infinity, by now I'm sure kuti munoziva this is the symbol for infinity. Saka kuramba tichiverenga unendingly, that's what infinite refers to. The formula we use kana taudza kuti it's a sum to infinity, it's simply a over 1 minus r. And kana muri mathematically witty, you can compare this with sum of n terms. moona kuti nemhaka yei zvasiyana uye zvasiyana papi. Panapa iyi ingori a over 1 minus r. Nemhaka for sum to infinity tisina 1 minus r to the n. You can ask yourself that if you are mathematically witty. Maybe you might come to some reason. From this takabva tainda pachi series expansion. Now pa series expansion takabata zvinhu zvitatu zvatiri kuda panapa. Chekutanga chatakabata binomial theorem. Tikabata universal expansion theorem. Tikabata Pascal's triangle. Anditi. Saka takatarisa binomial theorem, which I'm going to abbreviate BT. BT, binomial theorem. Takati, the way we state it, tinoda iso a plus b to the n, like this. Inenge iri equal to n choose 0, a to the n minus 0 multiplying b to the 0, plus n choose 1, a to the n minus 1 multiplying b to the 1, plus n choose 2, a to the n minus 2 multiplying b to the 2, plus and so forth. Ndo madaniro atakaita. Saka iyi inongoshandiswa kuexpanda my expressions anenge ane two terms are raised to a certain power. But when it comes to conditions associative neaya, takaona kuti n iyi inofanirwa kunge iri a positive whole number. Ndona yangoripo positive whole number. Takaona zvakare kuti a uno ushu kana kuri kuti term yedu inenge ine an unknown and a number, a inofanirwa kunge iri a real number. Anditi ndozvimwe zvatakaona. So those are the two conditions associated with the binomial theorem. If you want some examples of how it's done, we have lessons. This is just a summary lesson. Tichibva panapa takabva taenda kuchi universal expansion theorem, which I'm going to abbreviate UET. UET. Saka for the universal expansion theorem takati ingeri 1 plus x to the n, which is equal to 1 plus nx over 1 factorial plus n minus 1 x squared over 2 factorial plus n minus 1 n minus 2 x cubed over 3 factorial and so forth, like that. Saka ndo zvatinenge tinazo izo like this. So those are the two formulae kana kuti theorems which we worked with. Panapawo takaona kuti n can be anything. N unowe has restricted as in that n can be anything. Anything yacho iri kureva kuti it can be a whole number, it can be fractional, it can be positive, a positive number, and it can also be a negative number. It can be anything. Chakangokosha panapa kuzorangarira kuti sometimes tinofanirwa kuita factor out something, and when we factor out a number tinofanirwa kuita factor out with a power, an associated or associative power. Okay, Pascal's triangle PT. Saka Pascal's triangle manje chakakosha kugona kuidraw. Firstly hainetsi 1 1 1 1 ngatinyatso kuita zvakanaka. It's 1 andika 1 uyu 1 1 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1 and 1 6 15 20 15 6 1, like this. saka 2 matems aya anenge achiedana achiti pa-e ndozviri kuitika panapa. 1 plus 1 ndi 2, 3 plus 1 4, 5 plus 10 15 like that. Saka aya machia ma-coefficients handiti. Saka tikada kunyora a general example, let us use 5. Tikati a plus b to the power 5 inge iri equal to, tinotanga na 1. 1 times chi, saka ndakandinyorese manyoro andifunga kuita ndozoinyora manyorore munhu anenge azvijaira. Saka po inge iri 1a to the 5b to the 0 plus 5a to the 4b to the 1 plus 10a to the 3b squared plus 10a squared b cubed plus 5ab to the 4 plus 1a to the 0b to the 5. Manyorere munajaira, it's just a to the 5 plus 5a4b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the 4 plus b to the 5 like that. Saka ayo ma coefficients acho anaya 1 5 10 10 5 1 anditi ndo ashanda apa 1 5 10 10 5 1 like that. That's Pascal's triangle for you. Saka after taita Pascal's triangle takabva tapinda mu the behavior of sequences. Saka tiri pa behavior of sequences, ma behaviors api atakabata. Takataura about periodicity kana kuti periodic sequence. Takataura about an oscillating sequence. Takataura about a diverging sequence kana kuti divergent sequence. Tikataura about a converging sequence. Saka periodic sequence ndo yatakataura tichiti after certain terms inotanga kudzokorodza. An example would be 1 2 3 1 2 3 1 2 3 and so forth. Saka iri kuti after certain terms, in this case 3 terms, iri kubva yata repeat. Saka it's cyclic in nature. That's periodicity. Oscillating takati inenge ichichinja chinja -1 inenge chinja sorry, negative positive negative positive negative positive. And an example we worked with can be 1 and minus x. Let me use a different color but 1, then apo yobvaitachi minus x squared minus x cubed x to the 4 minus x to the 5 and so forth. As you can see, positive negative positive negative, that's oscillating. Then takadefine a divergent sequence as kutangira inotangira pa a certain position ichenda, and like what we have been learning all through 2 4 8 16 so forth. And that's an example. Iri kutangira pana 2, saka inenge ine a specific a. Then manje tichitaura pamusoro pe converging sequence ndo yatakati it's in a limit to a certain value, and in our example it was 3, and it approaches a fixed value in infinity. That is what we spoke about. So I ndo my behaviors being summarized. Then tichibvapo takabva tazoenda kuna mukoma sigma. Tikati sigma zvinoreva kuti chi, this is the sigma notation, inoreva kungoti summation kana kuti sum of, like this. Saka tikati the sum of r squared from r is equals to 1 to r is equals to 4, and this is an example, sum of r squared from r is equals to 1 to r is equals to 4. Tinogona futi kuva another situation where we are having sum of r squared from r is equals to 1 up to infinity. Saka that's summation. Okay, saka pandango bata just as a reminder everything which we did. To conclude this lesson, let me just write down the formulae. And I'm going to write AP and I'm going to write GP. But tunotanga nechi the nth term. Saka for the nth term, AP ingeshiti the nth term is equal to A plus N minus 1 times D, like this. Then GP kana titaura pamusoro pe the nth term, ingeshiti the nth term is equal to AR to the power N minus 1, like that. Then tichibva pa the nth term tunoenda pachi pa the sum of n terms. Sum of n terms kana kuri ku AP inenge ine tuma formulas. It's either ichati Sn is equal to n over 2 2a plus n minus 1d, kana out more simply ichati Sn is equals to n over 2 a plus L, like this. But kana tiri ku GP inge ngorne formula 1, Sn for GP inge equal to a 1 minus r to the n over 1 minus r, like that. Saka tichibva panapa manji takuchenda kuchi sum to infinity. Sum to infinity panapa hapana chinhu, hatina sum to infinity. As sum to infinity yechi ye AP S infinite inge ngori equal to a over 1 minus r, like this. So this is very important. It's a chart inofanwa kunge iri mumusoro menyu. This is very, very important. I cannot begin to stress how important it is. Saka andizivi kuti zvinowanikwa here in your formula booklet. I'm not yet sure kuti inowanika here in your formula booklet, but I would encourage kuti mu cross check. Kana history imo formula booklet ma formulas which I highly doubt, zvinoreva kuti you have to put them and submit them to memory. Then amwe ma formulas atakaita, of course, tatuma illustrator. It's the binomial theorem, universal expansion theorem, ne Pascal's triangle. We illustrated them. So this is a quick summary of everything we learned. In our next lesson, we are going to be looking at questions, attempting past ZIMSEC and Cambridge questions. Have any questions? Don't hesitate to use the comments. Want to join us through tutorship and extra lessons? WhatsApp us on the numbers which are going to appear on your screen. Thank you.